Hello, everybody. Sorry I'm running late. I apologize for being 9 minutes late. We were starting on time, but my internet decided to shut down, so I'm actually hotspotting off of my phone. So we'll see how this goes for a little bit. And they're working on trying to get it rebooted. But so I do apologize. Thank you for sticking with me. How's everyone doing tonight? We are going to be working on the finalization of the Podium pedestal. And one thing that I want to note about that is you'll see in just a moment, there were some design changes. I'll explain everything as to what the design change was. But I worked all weekend trying to figure everything out with the curved profile of the drawers. I couldn't get it. Some commenters commented about, maybe trying to use thicker drawer fronts or something, and it was becoming too much. And I'll explain it when we get in there in just a minute. Let me get my other computer connected. Let me see what we got here. Give me just one moment. I'm going to connect my other computer so I can actually show the screen and all. All right. All right. Well, hopefully there's some people watching tonight. We'll get things rolling in just a moment. All right, let's see if we can do this. Okay, and I'm gonna need your hey Brooks, hey NL Fawcett. Thanks for joining us from Illinois. And again, welcome, Ronnie Probert, Troy Pritchard, JR, David. Let me see who else popped in early today. Midnight Sun Woodwork. Thank you for popping in. Okay. So if you recall, and let me go back and I'll unhide everything, unhide all. If you'll recall, we ended the class with the, talking about coming up with a concept for this curved profile. And this is just how I ended it, trying to figure things out. But the drawer fronts and the curve and everything, it was becoming too much with the angles and everything. And I searched the entire internet for curved, dresser drawers, and I couldn't find anything on the World Wide Web and on YouTube and everything. I'm like, well, if nobody's doing it, there's probably a reason why. But one of the commenters commented, said, hey, what about using 2x4 material, and so that way the backs of the drawers could be straight, and then you have material to remove that meat for the curve. And that is a possibility. It could possibly work, but I worked hours and hours and hours on it, and I just couldn't get it. I honestly couldn't. And I know my limits. I just had to say, hey, I can't do it, and if I can't do it, what the hell am I trying to teach it for? Right. Kind of thing. So, that takes us to a design change here where we're going to, instead of the curved front, we're going to have a sloped front, an angled front and everything on the drawer. And let me, hide this again. But, and with that, let me hide this. The drawers and all are going to be very basic, simple construction. The fronts of the drawers, and let me hide a couple of these. Let's see here. The drawers are going to be assembled with pocket screws, and if you don't have pocket screws, you can glue. You can brad nail, screw together, whatever you want to do with your drawers. If I grab one of these drawers, let me see here if I can. It is super simple construction. This is a computer desk for the shop. It's not, an heirloom piece that's going in my, grandchildren's home or anything like that. So for the drawer construction, the bottom is going to be basically just 1/8 inch plywood. It's going to be glued and tacked on, brad nailed on. The fronts will have an angle to them. So the angle, just so you know, let me get my protractor out. Where is my protractor? All right, let's try that again. So about 74.4 degrees, 74 degree angle. 74.4 is what it is. But so the drawer front, sorry about that, ladies and gentlemen. I blacked out for just a moment. Not me personally, but my computer. Let's try that one more time. Let's see here. I'm going to go through, and we should now be connected. My apologies again. I don't know what's happening, but I blacked out again. My computer screen did. I'm hoping that this is not a continued thing. But long story short is the drawers, the front board of the drawers and the front of the sides of the drawers are going to have an angle cut in them. If you have a miter saw, that's going to be the best way to get the drawer parts cut. We're not going to, we can also try to do it on the CNC, but not everything is done on the CNC, guys and girls. Sometimes we need to use other tools. The drawer fronts are going to have let's try a different angle here. They're also going to be at a table saw as well too. They're going to be a 74 degree angle. So from 90, on your table saw, it's going to be like 90 from 74, that is 26 degrees, right? 70, 80, 90, 16 degrees. Why am I getting so stupid lately? 16 degrees. Thank you very much. Thank you. It's been a long, long day. So roughly about a 16-degree cut on the edges. You would cut one side, flip it over 180 degrees, cut the other side, so you can see that the angles are one's a kind of an outside angle, the other's kind of an inside angle and everything. But this is, what we're going to do. And what I decided to do is someone else commented in the comments about, hey, if you're going to recycle the current trunnions, these trunnion brackets that you already have, then the viewers, or the ones that are going to be making it, need a resource to turn to, and I looked all over the internet for them, for brackets like those, and I couldn't find any. So I ultimately decided that I'm just going to let's see if I can get things to come down here. Just going to we're going to make these. We're going to make them out of 3/4 inch material, 5 inch by 5 inch, and we'll lay everything out in Vectric here in just a moment. But we're going to make those in Vectric. Ignore the my bracket is kind of out of whack right over there. This one is correct over here. But we're going to be using 1-inch dowel stock, and we're going to have 7/8 inch dowel stock. So we're going to need 2 36-inch by 7/8 inch dowels from Lowe's, and then we're going to just need one 1-inch diameter dowel, and the length on that, we're only going to need 2 pieces that are probably about 5 or 4 or 5 inches and everything. So well, Steve, I have the brackets. I have the ones recycled from there, but for the people that want to make this project at their home, they don't have them, right? And I could not, I looked, I scoured the internet, and I couldn't find anything that even resembled what these brackets look like or anything. So unfortunately, I didn't have a source. Now, the push button mechanism, so that the drawers can just get pushed ever so slightly, and then they'll pop out for opening and everything. I did find those at Lee Valley. And it's going to be the concealed push button items versus the cabinet mount. And they're about $4.30 a piece, $4.30 a piece. And the length is just going to be 2 inches. I'm just going to go with 2 inches on the length and everything. And these get drilled on the back of the dresser drawer, on the sides, on the back. The holes get drilled in, and these get pressed in. So that way, when the drawer goes back, that plunger will push against the back of the cabinet. And then when you lightly push it in, it springs it open. Okay. So that's the push open mechanisms. I found those at Lee Valley, push open mechanisms at Lee Valley. And they're about $3.60 a piece for the 2 inch and everything. So that's where we're going to go. Brooks, could you fab them on the CNC in aluminum or brass? You sure could. Absolutely. You could. Now, most CNCs are, wood routers. which can carve non-ferrous metals, aluminum, copper, brass, titanium, and bronze. It depends on the power and the rigidity of the machine, of course. You would have to take it slow and easy, but you absolutely could, for sure, 100%. What we're end up doing here is this is going to be 3/4 inch stock, and we're going to be milling away 3/8 of an inch of material. So that'll give us a lip here that we can screw in to the bottom of the tabletop here. And then there's going to be in this dowel, there's going to be tapped and a threaded insert. It's going to be drilled with a threaded insert in there. So we'll have a star knob and a 1/4 20 bolt with a washer. It's going to go in here into that threaded insert, so that gives us the tilting and everything. This can easily be made out of wood, but yes, with a CNC Brooks Martin, you absolutely could. It just depends on, the rigidity and the power of your machine. Like even the 2440 could do it. I've cut aluminum parts on it before. You just got to take it slow and easy. It's a dry cut. There's no lubricating and everything. So you've just got to take it slow and easy with shallow passes and all. But everything I'm going to be doing, the 1-inch tubing, the square tubing, the 1x1 inch square tubing is going to be aluminum. And the square bracket that kind of slides over that transitions from square to round, we're going to make that out of wood. And again, that could be something that could be milled out of a non-ferrous metal, but we're going to make it out of wood in this episode. And so with the project here, I'm going to go through and save this. Well, I need to get rid of this extra drawer here. Let me go through and unhide the last things here. Let me get rid of this, copy this drawer. And we, if I ever come out with a way of doing something like this, I'll let you know. But it honestly, it was just too much. I spent all weekend and Monday and then today, some parts of the day, trying to get it, and I couldn't. I honestly couldn't. I had to say I just couldn't do it. I had to throw my hands up and say I just can't do it. So that's why we landed on this design. I'm going to throw this out, but what I'm doing for you all to make up for this, to make up for the design change, is I'm going to teach you how on the side panels, we're going to cut a decorative side panel for the side panel of the cart. And it could be any kind of shape and everything, but I am going to show you, I'm going to teach you how to make this pattern from scratch for the side panels that are going to get cut out. So we're going to do that in just a moment. And then we're going to import all the parts up. We're going to import all the parts in, not up. We're going to import all the parts in from SketchUp into the Vectric software. We're going to get them laid out, and then we'll start working on tool paths and everything. I'm not sure, Brooks. I'm honestly, I don't know. I honestly don't know. I beat my head. I stacked material where I glued extra material on the back so that there would be material to be milled away. I didn't, 2x4 material that just left me with, construction type pine and everything. I didn't have any wood. So, gluing 2 pieces of 3/4 inch material together to try to get enough material to get a curve. There's a possibility that could be done, but it wasn't working quite right. And I wasted hours and hours and hours on it. And if I can't figure it out, there's no damn way I'm going to try to teach it to y'all. It's just a waste of your time. it's a waste of your time, and I've wasted your time enough as it is every other week, you know, with stuff that you know, I get stuck on or something like that, and I didn't want to just waste today on trying to figure something out that I couldn't figure out in 4.5 days, right? So I don't know, Brooks. I honestly don't. But I'm going to teach you how to make a decorative side panel that's going to get carved into the panels, a simple V-carve type project. And there's all kinds of different designs you can use. This is the pattern that I landed on. It's going to teach you about, you know, creating a, shapes, and then how to array those shapes, how to trim that array to lay out in a particular area, right, of the carve and stuff. So we're going to learn that, and that's going to be kind of the decorative element of this CNC tray, right? And all. So the drawers are going to be flush mount drawers with the sides. And again, there's not going to be any hardware, no knobs or no handle. It's going to be slimline basically. And they're going to be pushed open. So when you push, they'll spring open, and then you can just grab them to pull them open and everything. Now, the one thing that I have not worked on in here yet, which we kind of need to, is the drawer slides. Now, there is there's a lot of different ways to do the drawer slides. I'm making them out of wood because of the angle and the length changes and everything. I'm making the drawer slides out of wood. One of the things that I need to take into consideration is that when the drawers come out, as of right now, they're going to be able to pull out completely. Now, there was a few drawer mechanisms that I looked at that I really, really liked. I'm going to share one with you from Shopsmith. And I really liked the design a lot. And let's see here. Drawer slides. And bear with me just a second and let me get back to it. Wood drawer slides. I don't know. I closed the window, and it's not Shopsmith, it's Woodsmith. I'm sorry, Woodsmith, for getting your name wrong there, guys and girls. Woodsmith magazine, they have a really creative article. It's not really an article, it's just a very short story or short kind of post. I guess you could call it an article with instructions of this drawer slide that is actually pretty darn creative. Basically, your runner on the drawer, inside on the length of the runner, there is one piece that is kind of separated from the rest of the runner. Now, these runners are they are 1/2 inch thick by 3/4 inches wide, and the little swivel drop down is 3/4 inches wide, but it's 7/16 inches thick. So that way it can swing without any hang-ups or anything like that. And when this drawer gets pulled out, when it reaches this opening here, so as the drawer comes out, when it reaches the opening, the let me see if I can zoom in for you guys and girls. When it reaches the opening, as it comes into this opening here and everything, it falls down and it cannot go back because of its position and everything. So you can't pull the drawer out. However, because of the spacing here, when you go to push the drawer back in, it's enough to fold that lever right back up in so it closes. It's absolutely ingenious in my opinion. I think it's just a great little design for wooden drawer slides with a stop. And I really wanted to use that, but some of my drawers are only 2 1/4 inches thick, and that's exactly what this width is from these stops and everything. So if we look up here, the overall stops 3/4, 3/4, and 3/4 is 2 1/4 inches and everything, and that's right at my drawer and everything. And so we're not going with this, but you all should bookmark this. This is woodsmith.com in the article /article shop-made-drawer-guides, right? It is, and I'll actually paste that in there. Check out Woodsmith. They did a great job on this, and I plan on using this. I plan on using these drawer slides in my bench, my workbench drawers. I think it's great and everything. So let me paste this in the chat here. Give me just a second. Woodsmith.com /article. I couldn't paste it because I'm on 2 different screens. shop-made-drawer-guides. GIDES. All right. There you go. All right. So JR says, make a U shape in a 2x4. Keep the dowel rod long and keep the side brackets Yep, JR. So, okay, JR, let me pull this up on the screen. Let me get off of Shopsmith. We're done with Shopsmith, but that's a wonderful article. I'll show you another. Option for a drawer slide as well. But let me put JR's message up on the screen here. He says, make a U shape in a 2x4. Keep the dowel rod long and keep the side brackets the full 3/4 inches thick. I'm assuming that instead of the 1-inch square aluminum, you're wanting to use a 2x4. Have a U shape cut into it for the. Are you talking about for the dowel rods going up and down, or are you talking about something else, JR? Let me know. And Brooksmar says, Epic Upcycling has a great example, captivating drawers in his video, machinist tilting drop-down drawer tool chest made from scrap. Cool. Epic Upcycling on YouTube. Epic Upcycling. I'm assuming, Brooks, that's on YouTube, right? That's great. And one of the ones that I really liked that I thought was another creative way to do drawer slides. Let me see if I can get her. Let me see if I can get her post and images put up. Now this is 3x3 custom. Bear with me a second. I'm going to get past the commercial here. Pause. Let me pull this up. And this is 3x3 custom tamer. And in her video, let's get past the blur that she's got going on here. Let's see, bear with me. Let me back up to here. Using dowel stock as drawer slides. She did a great job with this project, and in the making of it, she did a phenomenal job with the project altogether. But she, using router bits and all, in our case, we could do it as a 3D model, or we could do it with a kind of a box core bit, wide diameter box core bit, depending on how wide the dowel is. But the drawer sides have a groove cut into them. The side of the cabinet has a groove cut into it for the dowel. And then between the two pieces, between the drawer and the side of the cabinet, there's an 1/8 inch piece of stock kind of to give that spacing, so you know exactly where to. So there's place, so there's sliding room and everything. And the when it's all said and done, her drawers were excellent with the opening. I don't want to get a copyright strike or anything with audio and stuff, but I'm giving her a shout out, so hopefully she doesn't get on to me. But these drawer slides, that's the dowel. That's another ingenious idea that I would never think of. Now her drawers, she made a follow-up video. Her drawers pulled all the way out, or they also pushed too far back. They didn't stop at the front. And she made a spring with a piece of dowel, torsion spring. She cut short. She epoxied the two together. She drilled a hole in the side of the dowel to where the spring could be pushed in and then compressed. And it gets caught on the back or the front here, so it can't pull out or go too far back and everything, which is ingenious. This design will not work for my cabinet because I have a solid cabinet door, so that doesn't work for me unless I put some kind of slot in for the spring dowel to slide back and forth so it kind of stops, which that would work in that case. And we could probably incorporate something like that into the drawer. But I thought this was an ingenious way of creating wooden drawer slides as well too. So 3x3 custom tamer, great job on that. All right, so for me, as of right now in the project, I have no drawer slides, right? So I haven't made them yet or incorporated them into this design and stuff. And that's going to play a big role on the width and the spacing of the sides and all. I have plenty of room. All it's going to do is these parts are going to just come out a little further depending on the thickness of my drawer slides. And so what I decided to do is I really liked the Woodsmith ones. I liked the dowel ones. I thought that was a great concept too. And it could be easily incorporated into this design. But in the end of it all, it just needs to be able, the drawers just need to be able to open and close. They need drawer slides. So I'm just going to, and you can call me, you're like, are you a woodworker? But I'm just going to use 1/4 inch plywood strips for the runner and for the what the runner slides in between and everything. But I could also create a board that comes across, which JR is talking about, like a shelf. You know, I could put a shelf board in here so the drawer slides back and forth on that and everything. That would be an easy way of doing it for sure, JR. You know, just putting in some dados here and putting a shelf board in, right, in between those. One, that would help with crap falling from one drawer to another or something like that. Dust getting down into all the drawers if they go in, you know, it kind of would be a dust deterrent and all. So that might be a good way to go. And I like that. I actually kind of like that. So, and Jim G says, on your 2-inch drawers, narrow up your slides from 3/4 to 1/2 inch, and there will not be as much weight. True. So you're talking about, Jim, you're talking about on the drawers, the sides. Right now the drawers are 3/4 inch, you know, and I like a 1/2 inch drawer, but I also like a, hold on a second. Let me see if I can bring me back up full for just a moment. So I also like a 3/4 inch, you know, drawer as well. Now this one is just select pine. The fronts and the backs are pocket hold, and then the bottom is pocket hold in, you know, flush and everything. And then I'm using, you know, long reach drawer sides, and then my drawer fronts get screwed to that, of course. Now this is just one of my dresser drawers. I got some dressers that I'm in the process of assembling and stuff. And I like a heavy drawer. I like a 3/4 inch drawer, but on something like this, a little utility cart and stuff that you're rolling around, weight might be a thing, right? The drawers, I mean, we're not gonna have big power tools or anything in these drawers and stuff, just, you know, little CNC accessories and everything. But a 1/2 inch drawer, you know, 1/2 inch material drawer would let me move this out of the way. All right, accidentally destroy that one. The 1/2 inch drawer material could be, you know, good as well too. And forgive me, guys, if I'm misunderstanding what you're trying to say. I'm just interpreting what I'm reading and seeing, and hopefully I'm right. The slides with the catch. Oh yeah, so they're 3/4 inches wide, 1/2 inch thick, and then the little drop down catch is 7/16 inch thick, so it moves freely and everything. But you're saying take that 3/4 down to 1/2 inch, and you know, you have to be talking about the drawer because you said the word weight, because the drawer slides, there's no weight in there. So let me know. John Hines on YouTube has a lot of wood slide designs. Oh yes, yeah, John Hines does. There's, you know, I had a marathon on drawer slides, right? There's a whole slew of them and everything. I think what I'm going to do with this is that this design, and if I change, I will let you know, but I kind of like the shelf idea. And let me show you how I would draw that in if I were to basically, let's come in here and hide some things. Get my keyboard. We'll import all these things into Vectric, and we'll lay out the toolpath here in just a moment. Hide that. Hide that. Hide. Drawer fronts I can leave. Let's take away one of these. Hide that. Okay. So if I was going to do that, that would turn, because I'm going to carve on this outside panel, you're talking the slides. Okay, Jim. Ronnie, you need to go, Laney, you need to go back in the corner. Let me know what that, let me know what that means. When I used to get sent to the corner. Oh, yeah, sorry. I need to go back in the corner. I know what you mean now. I thought you were sending me to the corner with a dunce cap on or something. Like how we used to get punished as kids. All right. So there we go. Back in the corner. Now I know what you mean. So what I'm going to do with this, I've got everything hidden except for the parts I want to kind of keep that are going to be important to me. I kind of like the shelf idea. We will do a project. I promise we will do a project coming up with those drawer slides. Like I said, I'm going to be incorporating those with the drop down. I love the Woodsmith design. I thought that was just clever. But for now, I'm going to, I like just the shelf idea. So what we're going to do is I'm going to come in with the tape measure tool, and I'm going to bring down a guideline to the bottom of each of these drawers. Let's turn on the guides so you can see what I'm actually drawing. And let me get rid of, there's a whole slew of guides here. So let me get rid of those for right now. I had guides on top of guides on top of guides. Okay. So let's get back here real quick, and then we'll get into Vectric. But we're going to take our tape measure tool, and when we use the tape measure tool, it kind of creates guidelines, and I'm going to snap it down to the bottom of this drawer here. And then I'm going to come down, and I'm just going to use 1/2 inch material. And since it's going to be, I'm going to use plywood for this. And since it's going to be that, it's going to be 15-30 seconds. The actual dimension for the plywood. So the let's go back over here and let's come down. Oops, come down, and I'm actually going to type in the fraction 1532 and create that second guideline there. Now I'm going to do this all the way down. So snapping a guideline to the bottom of the drawer and then coming in and creating another second guideline to create, that's going to represent where my dado is going to be. So I'm going to be milling a dado in here for the drawers to slide into. And so once again, we're going to come down and I'm typing in, as I drag that second one down, I'm just typing in the 15-30 seconds and hitting enter to create that. And so pulling the next guideline and all right. Oh, that guideline went into 15,000 and something. I forgot the as a fraction. All right, now down here, I'm not going to have the room for a 1532 dado and everything, but there's a bottom on this, so it can kind of slide on that bottom. And hey, Kevin, wow, thank you. So this drawer, I can just go ahead and select it. And then let me get back under here. And if I hit the M tool or M on the keyboard, that's the move tool, and I can just move that down and kind of snap that to there. So that drawer will just slide right on the bottom there and everything. So now that I have those guidelines and everything, I can go ahead and I'm going to select all of this. I'm going to hold down the shift key and turn off this side panel. And I'm going to hide everything out of the way. So I just have this side panel here. And I'm going to bring in the tape measure. I'm going to bring a guideline up just to the, not to there, but let's do that a little bit differently. I'm going to bring I've got to draw a line, so I'm just going to double click on this. I'll use the offset tool to help me create my line here. And what I want to do is I want to kind of just create a stop for the drawer. I don't want to have to cut an angle in the end of the plywood or any of that stuff. Just a simple stop. I want to be able to just slide the drawer in and be done with it. As the shelf, this shelf, if I'm going to do that. And also, I'm just going to, I'll just use the rectangle tool. And there's no particular place. I'm just going to come in and totally miss that all together. Let's try that again. Okay, let's try that one more time. Sorry, ladies and gentlemen. And then I can pull this. And what I'm doing is on here, I am bringing this in just, it's 3/4 inches thick. I'm going to be carving on the back side and everything. So I'm just going to come in either 1/4 inch or 3/16, just enough that'll hold some material. So I'm okay with 1/4. And so I'm just going to push that in because that's going to be the shelves that that's going to be the dados that these shelves are going to sit into. And so for each of these, there's no particular place. What I want to do, and so you understand what's happening, I want to at least be, it's not going to give me, it's going to kind of be a pain in the butt with this. Let me go this direction. I want to at least be, more than 3/4 of an inch away from here because I have my drawer fronts that are coming in, right? So I'm too close here. So I need to back that up and this will be, let's do it this way. .75. that will kind of give me my no-go zone. That's where the drawer fronts are going to be. Okay. So, because they sit flush. So I'm going to make sure that my shelf stops before this line here and everything. So let's go ahead and go back and let's do that again. And I'm just going to, let's take and draw a line. Let's not be right up on. So let's go with another offset. And I'm just going to go a 16th. 0.0625. So that will be my, that corner right there I can use. That'll be the corner that I can, not there, but that'll be the corner that I can draw up to for my dado. Push pull that. And first of all, let me get rid of these two lines. Okay. Push pull that in. And again, 0.25. So what I want to do is I want to, end right about here. That'll give me a 1/16 of an inch of clearance and everything for that shelf and stuff. So R for rectangle. So I can quickly come back and then P for push pull, and I can push that in. Now let me undo that. I got these two lines back here. So let me see if I can go through and just actually delete these back lines. I only need the front lines. Oops. I only need the front lines. So I don't need these back lines in my way. All right, good. So I don't need them now, and I don't need this top and bottom line. Okay. And I don't need this line here. So this is all that is just a visual guide for me. Now I can push pull. Let me turn this sideways so everybody can see. P for push pull, just push it back and type in 0.25 and hit enter. Switching to the letter R for rectangle, taking and drawing a rectangle along the guidelines up to my 1/16 of an inch line there. Switching to P for push pull tool, push it back, 0.25, enter. So it's very quickly we can switch from one tool to another. R for rectangle, come in here and draw this one. Let me snap to P for push pull, push it back, type in 0.25 and enter. Once I create one side, then I can mirror and copy it to the other side. I don't have to do it twice. R for rectangle. Come in here. P for push pull. Push that back, 0.25 and enter. All right, once that's done, I can now come in here, and now I have the dados for where my shelves are going to go. 1/2 inch, 15, 30-second shelves. And now I no longer need these lines. Okay, now I can take this part here, and I'm going to hold down, I'm going to hit the M key for move, and I'm going to hold down the control key to move a copy. And I'm going to snap it right up against here, and then I'm going to move it over. I'm going to type in, I believe it's 12. Could be a little further. And oops, I didn't need to do a copy. I just need to move this one. So I'm going to move that over. I'm going to type in 12. And then the dados are on the wrong side. So when I right click on this, I can flip along the green axis. Oop, not the green axis. It's going to be flipping along the red axis. And No, only one more to go. Flip along the blue axis. There we go. That'll turn that inside. Oops, don't move it. So now I have those two here. And when I go through and unhide everything, all right, I went out too far. 12 inches was too far. So let me go in and put that in its proper place. Let's take this and move. And that just gets snapped right into place there. So now let's get rid of the back again. Hide that. And so now you can see I have the grooves where the shelf boards are going to go. Now, creating the shelf boards is very straightforward. We're going to just use the rectangle tool. We're going to just draw a square filling in that open area right there. And on the front side, well, let's do it for all the back. So we just literally draw a rectangle filling in that area there. One more. And then on the front here, I'm going to select all these drawer fronts and hide them. And the right below the drawers, my rectangle, which is here, P for pull, push, pull, and I'm literally just going to push, pull that up to that stop. Okay, so that creates that stop. So P for push, pull, and just pull it right up to that corner. I'll get that little end of component area. Come here, pull that. Make sure that when I'm, push pulling this in, that I snap to that end point. Two more. And one more. Okay. Now I've created those shelves. And I want them to all be components. So I'm going to triple click. It doesn't matter where you click on it, just somewhere. Triple click to select all the faces. G for group and enter. Triple click, 1, 2, 3. G, enter. 1, 2, 3. G, enter. 1, 2, 3. G, enter. G, enter. Now, why we want to do that is so now this is one group. So if I wanted to pull this shelf out, right, I could pull that out as a whole component and everything. So it's one component. All the faces aren't separate and things. So that's going to go there. And so those drawers will just sit on the shelves and they will, just slide in and out. There's not going to be any movement side to side. They're going to be a nice fit and all. Now, drawer stops. What we can do on the drawer stops is I could have a little piece of material. Now that I have these shelves here, I could have I could glue in a piece of wood or something here that hangs down. I could do the same thing on the back of the drawer so that when it pulls, it it only goes so far and it won't come out. But I'm not going to worry about that right now. All right, let's see here. Shelf rail. What's a shelf rail? Brooks Martin, help me out. Did I say the word shelf rail? I might have. I don't know. But let me know what a shelf rail is. All right. So Excuse me. Let's go in and get rid of that. Okay. So now that is going to be all of my components for this project. So let's go in and unhide everything. Now we have all of the components. Now this one, on my back, my shelf goes all the way to the back here. So we're going to rabbet the back. One last thing that we're going to do here is we're going to rabbet the sides, and that will hide these openings right there. So they're not visible. Let me do that really quickly. We're going to come in here and we're going to push pull this in a 1/2 inch. That's how thick the back wall is. So we're going to go 0.5 for each of these because I went all the way to the back end. Push pull 0.5. It's always one thing or another. Push that in 0.5. No, I'm not going to do the sliding rails. We will do a project with the sliding rails, but we don't have enough time to redesign this whole thing to make room for sliding rails because I designed the shelves or the drawers to be tight in there, and so JR, threw out the idea of the shelves, and I like it. It's a simple solution. P for push pull 0.5. All right, last one 0.5. Now in here the what I do to one side will get done to the other side over here. So I'm just going to take a tape measure and bring a guideline over to this edge here. It's a 1/4 inch in. And I can now go in and push pull, or I got to draw a line first. Sorry. Let me draw a line on that guideline all the way down. And then I can push pull this in that 1/2 inch, 0.5, 0.5, 0.5. We're creating this rabbet on the back here. 0.5. All right, because this component is a copy of the one on the right here, everything that gets done on one side gets done on the other. So now I'm going through and deleting these lines. I don't want those lines showing up when I import the vectors into Vectric. I'm going to be creating this rabbet cut with a pocket toolpath, and I don't want those lines there. Okay. All right. So now on my back part here, we're going to move this over to there. double click on it to get into the component, and then we're going to push pull this side over here over to there. Okay, so now that'll sit in that pocket. All right, so let's go ahead and hit let's go ahead and hit save on this, and let's go over to Vectric and let's import all of these parts. Now I don't need to break them up or anything to import them into Vectric. So let's go over to, I'm using VCarve Pro for this. Let me turn on my mouse highlighter. I should have had that on the whole time so you can see where my mouse was. All right, we're going to create a new file. Now, there's going to be multiple sheets on this. I'm not going to try to carve all of this out of one, board or this or that and everything like that. So the sheets are going to be, the parts are going to be imported in. And then based on the part sizes and everything, we're going to, I'm going to create my board sizes or sheets, if you will, based on that, and then I'll nest the correct parts on the boards and all for the layout and stuff. So for just the initial import, I'm just going to kind of create a generic kind of work area. So I'm just going to go 24 by 24 by 3/4. Touch off on the material surface. I'll start from the center for right now. Very high resolution is fine. And I'm going to import a vector. And we're going to import from documents the Podium. Now, in here, there are 58 parts. I don't need to orientate anything in particularly, as far as the face. So I'm just going to let it auto orientate them coming in. I'm going to, if there's any circles or any polygons where the lines are kind of, polygoned around, I want them to create circles for that. If there's any arcs or anything, I want to refit those arcs to their boundaries. I want to keep the components, all those shelves, they're components, all those individual parts. I want to keep them as components, and I want to kind of keep them together. So when I import, when I click OK here and all, that's going to bring in all of the pieces for this project. Now, the dowel stock we're not doing on the, we don't need on the CNC. The aluminum, brackets and all we don't need on the CNC. The aluminum, square tubing, the 1 inch by 1 inch square tubing we don't need on the CNC. But everything else we do, right? So the very first thing I'm going to do is I'm going to go through and kind of eliminate the parts that I don't need. And so the dowel stock, they don't need to be in here. They're just going to be in my way. The one more dowel stock right there. Okay. And I am good with that. All right. So now we have a bunch of different parts. Let's put them in perspective so you know what's what, right? So the shelves that we just created, that is going to be these parts here. 1, 2, 3, 4. And I'm sorry, the bottoms of the dresser drawers and the shelves are going to be these square brackets here. So I'm just going to move them over there along with this, 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 and that. Those, oops. Those can get moved over out of the way. These two, these are the bottoms of the shelves. Okay. Now let's go to our design, and we should have 1, 2, 3, 4, 5, 6 shelves, right? 6 shelves in here. And so the 1, 2, 3, 4, 5, 6, these are the shelf bottoms. And we're going to have 6 of those, if I'm not mistaken. Let's go here once again and hide that just for a second. 1, 2, 3, 4, 5 of the 5 of the shelves, and then there's 1 top. So let me measure the top so I know exactly which one. So we have 8 inches by 10.5. So one of those 8-inch by 10.5-inch rectangles, if I select that one, it's not that one. Bear with me. That's 9.5 by 10.25. All right. Did I pull the top over? 8 by 9. 8 by 9.5. 9 by 11.25. 8 by 10.5. There we go. Okay, so that one, it took me a minute to get it. That one is going to be the top of the podium. So that's not going to be one of that. So I'm going to have the drawer bottoms. We'll measure all these to find out what's what and everything. But here's your choices, okay? If you don't have a table saw, then you could lay these out on plywood if you have a decent size enough CNC where you could cut them out, cut those parts out, your plywood parts and everything out that you need. But they're square. There's no carvings going in them. There's no dados. There's no grooves. There's no nothing. They're just square parts. So if you do have a table saw, it's going to be easiest and best and quick to cut those parts out of the table saw. They don't need to be in this project. Very few of these pieces need to be in the, carved on the CNC. It all depends on what you have, what tools you have and what tools you don't have. So for instance, these are the drawer sides, all these sides with this angle cut on them, right? So we could lay these out on a board on the CNC, and we could just do a profile cut, right? 3/4 inch deep profile cut, and we could cut every one of them out on the CNC. Not a problem. But if we have a chop saw, a miter saw, we could even, if we had even a table saw with a sled, that we could change the angle and everything to cut those miters. If we have other tools in the shop, hell, we could use a skill saw with a speed square and, as a guide for our angles. We could, we could draw a line, but, we're trying to do, precision cut. So let's leave skill saw out of it for right now. But a miter saw, a table saw with a sled, or we could use our CNC, right? So use your tools. Not everything has to be done on the CNC is the whole point of that. So my question to you, and we'll let the group decide, do you want these sides with the angles? Do you want them laid out and tool paths created for them? Or do you want them set aside and that be part, we create the cut list for the table saw cuts or miter saw cuts, because we can create all the cut lists, we can write out and create all the cut list for all the parts and stuff, but or we can just lay it out and create tool paths, right? So let me know in the chat. Let's majority rules there, and we'll see what happens. But for now, I'm going to take all of the parts, and we have left side and right side and all that stuff. And you know, they bring them in upside down. It just kind of brings it in and everything. And so all I'm going to do is just kind of lay these out. And on a part like this where it's upside down, I'm just going to hit V for vertical to flip it, right? And our shorter shelf would go, try to put these somewhat in some kind of order. There's 6 shelves. Give me just a moment. There should be 2 matching parts. Okay, that's the left and the right. So sorry, I was like, why is that? Why is it the same at the same size? Okay, so let's come over here. Grab this. I'm going to hit V to turn that upright, and this should be the matching. That should be the left or right to that one. Let's grab this one, move it over here. I'm going to hit the letter V just to flip it upright. This is a bigger shelf, so that'll come down here. Let's see. Let's grab this one. That should be the match to the one I just had. Yep. So we'll set that there. Here's another one. V to flip that over. Might as well grab this one while I'm here. And I'll take both of those up. Okay, now this one goes there. This one is the match for it. Okay, 1, 2, 3, 4, 5. There's only one more shelf, and it's going to be the square shelf. So the bottom shelf is a 3-inch tall, just under 3 inch, 2.99, but 3-inch tall by shelf here. So these 2 boards are going to be that. And I believe those, if I stack them on top of each other, they are the correct size. All right, so that'll be, let me hold down the shift key and select that and pull that up there. That's the bottom shelf. And the other shelf should so follow suit. 1, 2, this one. There's the pair. I was wondering where it was. So that'll be the pair for that one. Okay. So those are going to be our shelf sides, our left and right shelf sides. Now, the square pieces like this, that's our shelf backs. And it could also be the shelf fronts. But the shelf fronts are going to be all of these with the lines here. Okay. All of these squares with the lines, and what those lines are representing. Hey, thanks, Kool-Aid. I appreciate that. What those lines are representing is, remember, on the shelf fronts, let's go back and look at that. On the front of the shelves, let me grab one here. move and just pull that out for a minute. There is an angle cut. When it's flat here, there's an angle cut on the top and the bottom. And where this vector is versus where that vector is, that distance, offset, let's call it an offset. So let's say this vector is here, and then it goes at an angle, and the other vector's up here. That offset distance is represented in the Vectric software by these two lines. So that's that angle cut. And what we have to remember on this is, and again, I would recommend these fronts be cut on the table saw, but those fronts there, we could technically, with a ball nose bit and a chamfer bit or whatever, create kind of some kind of, angled miter and all. Not going to be as easy as just running it, tilting the blade 20 or 16 degrees and making our cut, flipping the board over and making our second cut, right? So that's going to be the easiest way for these. But all of these with the double lines, that's the jaw fronts. That's the jaw fronts. So if I were to select the jaw fronts, and let's say that we move them here for right now, we have our shelf boards, we have our jaw bottoms, we have our jaw fronts kind of grouped together. We've got the little top to that, the top of the box. This board right here, you see that extra line that's right there, that extra vector? Well, I can almost guarantee that if I came in and looked, there is a going to be, an extra vector somewhere on my in my drawing that got added to this vector here. This is that, back panel. So what we want to do is we want to make sure we get rid of that extra line. So just use your scissors. You got to ungroup it. And then just use your scissors to trim that away. So that's what I said earlier. I said when I made those dados and everything, those vectors, and I went through and deleted all those extra lines, in there, because we don't want anything getting imported that we don't want. And it'll import every line that's left behind or every line that's created, that's drawn. It's going to bring in that vector, right? And sometimes when you're importing from SketchUp and stuff like that, it can be confusing as to, okay, what's that line? What's what? Now, on these trunnion brackets, we're going to redraw these, because this U that I drew, that was just for help with layout and stuff in the other program. This U isn't an actual realistic good tilt. And Vectric is my best friend versus SketchUp. SketchUp, I can do a lot of things, but I can do more in Vectric, right? So in Vectric, if I come in here, in, let's say in this this part here for a moment, let's ungroup it for a second, U to ungroup. And there are multiple circles here, right? And I don't want the polygons, I want the true circle, right? So I'm going to go through and select all of this, and I'm going to come in and I'm going to hold down the shift key and turn off the circle, the outside here. And then I'm going to delete all that inside stuff, all that inside trash. But, and the same thing here with these arcs, right? There, you can see that, right? You guys and girls, hopefully by now, possibly, you know how to identify duplicates. So when you're selecting on a single vector, and let's put it on the board. Let's grab this and put it on the board so we can see it clearly and everything. When you're selecting a single vector, generally it's a white and pink dotted line. If it's not grouped together, then it would be a pink solid line. But let's say it's ungrouped. It's white and pink, meaning it's a dashed pink line, but you can see the white background behind it, right? When you're selecting on a vector that is a duplicate, then that it's either going to be white and black, or it's going to be solid like, or you're going to have kind of these funky little, if we zoom in, you can see there's kind of like a double line thing going on there, but they're so close together, right? Those duplicates and all. So we're going to go through and we're going to select one of them and hit delete. And then the next one should be a white and pink dotted line, right? We got rid of that duplicate. Now, of course, if I ungrouped everything, I could right click and go to select all duplicates. When it selects all of them, I could hit delete, right? But I kind of don't want to do that. I don't want to do the bulk thing. I want to kind of do one by one, because some vectors I need, even though they're overlapping other vectors, I need them for a particular toolpath when you're importing from SketchUp. This is kind of a tip here. Don't just bulk delete duplicates and things like that, because some duplicates actually serve a purpose. We need that vector to create the rabbit cut or the dado or the groove, while the other vector that it's overlapping might be part of a profile cut or something, and we need to keep both of them, whatever the case may be, right? So in here, this vector right here is a duplicate of the main rectangle, but it represents where that pocket's going to be. Remember, there's a lip here. So it's a 3/4 inch piece pocketed down 3/8 of an inch to create that lip. So I need this duplicate, this one that's over there. I need that for the pocket, and then the remaining vector for the profile cut, right, to cut out. So those two vectors, even though one of them is overlapping, I need that overlap because I need to be able to use both of those vectors. Okay. So just keep that in mind. It's not always, it's a duplicate, delete it. In this instance, when you're importing from SketchUp, because SketchUp has just imported a 3-dimensional part in 2D. So all those vectors, basically are brought in kind of flat, right? So they're on top of each other and stuff. So, all right. And what I was saying about this, the reason why I love Vectric so much, let's say, for instance, that I come in here and I put in my 0.25, 0.25. I put in my 1/4 inch circle here in this U that kind of represents my bolt, right? My little wing nut and everything, my 1/4 20 bolt that's going to come in. And first things first, I want to bring a guideline over, and I want to kind of snap to the center of this 5-inch by 5-inch piece. And I want to bring my circle here over to that center point, right? So I want to kind of be in that center. Now, I'd like to just ideally, visually, I'd like to be centered up and down here. So that's that. Now, here's what I love about Vectric. I can take and select this entire part except for the circle. I can double click on this part, and on the center square right here, if I single click one time, it'll show my pivot point. It's not going to show my pivot point. There's my pivot point because my guideline's in the way. That's okay. But I'm going to take that pivot point, I'm going to select it, and I'm going to drag it up and snap it to the center of this circle. The center of this circle represents that post at the top of the round leg where this is, and it's kind of like the hinge, if you will, the pivoting hinge, the pivot point. So now that I'm centered there, I can grab any one of these blue things and I can pivot this part, right? And my lid, so my top is connected to this, right? My top is pivoting. It's pivoting, right? That whole bracket is pivoting. that whole top. Well, lo and behold, my wooden post ain't moving, right, in that circle. My center dowel isn't moving. I'm pivoting off that, but my bracket and my top are pivoting. Well, if I look here, my U shape, it's not the proper shape for the pivot, right? It's not the proper shape for the pivot. And and I knew that when I drew it. I just drew a circle and I cut the circle in half and everything. I knew that. It's got to be more of a sweep, right? It's got to kind of be more of a sweep and everything. And this vector, let me come in here and delete this, because I have my circle there. I know kind of where, this is where I need to be. That's where my, whole point is, and everything. But when I come in and create that pivot, if you will, I need my path where that bolt, slides in, that path and everything to kind of travel properly. So the thanks again, Kool-Aid, for that super chat. I appreciate that. So once again, let me close this for just a moment. If I come in here, let me turn off let me select this. Let me turn this off. When I come in, let me put that back up in the center. When I come in and I'm rotating, this part, I need to kind of create my path, right? So what I'm going to do is I'm going to look at where my circle is. I'm not going all the way to the edge, of course, right? But I'm going to see where my circle is here. On this bracket, I'm just going to kind of, pick a spot right there. And I'm going to Control-C, Control-V, copy and paste that. And then I'm going to go back and select my part again. And I'm going to turn off my original circle. So let's close this. Turn off the original circle. One of them is still selected. I want it to actually pivot with this part, right? And so I go back into my rotate tool. Got to keep putting my pivot point back in that center point of that circle. But now when I come to the other extreme here, I can come in and I can select that circle, Control-C, Control-V, copy and paste, right? Now, when I rotated this, right, this part, it keeps track of kind of, the angle that I'm at and everything. Well, it did before I clicked on net. It was 119 point something, but that's okay. I have my center line that I can work with. But I could have just had it go right back to zero if I wouldn't have been jumped ahead and clicked on something I shouldn't have clicked on. But let's go in and hold down the shift key, turn off one, close this tool now, turn off one of these circles. The other one is still selected. Go back in, get my rotate tool back opened up, get back to the center here. All right. Now I'm ready to pivot back and get, squared up again. Let's get, Oh, overshot that. It would have been super duper simple for me and easy for me if I would not have lost my measurement over there. I could have just told it to go right back to square. All right, oops, don't move like that. Don't do that. All right, now I'm going to actually use a guideline to help me out to get straight again. Okay. On this, once again, don't select the bottom circle. That needs to be turned off. Yep, that step would have been that step would have been so much easier if I would have not clicked on that. Sorry. Get back to the center there. All right, so now I'm just going to make sure that I have the two outside circles selected. I do. Okay, so now I'm just going to pull this down, and the shame of it is I wish my graphics would show up like they used to. For some reason over the last couple of days, my orange view showing where I'm pivoting and where I was and everything. All right, you see that right there? That pivot, I'm going to undo that because I'm off center. Close this. Okay, let me get back. Let me do that again. All right, all right, all right. Oh, don't do that. All right, somewhere along the line, I moved off center. Let me get back to there real quick. Okay. Yep. That's where I moved off center. Okay. So now I'm lined back up. So when I was rotating, I shifted myself. No, that's a no. So I had to back up. Okay. Double click. Rotate tool. Still off center. All right, hang tight, guys. This is critical. There we go. If I get off center, then that throws off the whole pivot. The whole, it won't work. So one more time. Here we go. We're going to select everything. We're going to close out of this. Drag this up. Make sure that I'm centered. Centered. All right. Turn off, hold down the shift key. No, see, that's where That's where it's going wrong. It's wanting to move, not deselect. There we go. It's wanting to move, not deselect. Okay. One more time, very quickly. Let's get all the way over to here. Come in, select this circle, Control C, Control V to copy and paste to drop a circle there. Close this tool, select everything, hold the Shift key down and turn off one of those circles. Now, click on this and open the rotate tool back up and pull this back over to that center. Rotate to the far extreme. Pick a spot, any spot. Close this tool. Double click. Or not double click, but Control C, Control V. Select everything. Hold down the Shift key, turn that off. Now, go back into the rotate tool. Pull that back over to the center. Zoom in, zoom in, zoom in. Get all right, still a little off. Bear with me just a moment. Man, it's a shame I can't grab that and then snap to that line. There we go. Okay. Thank God I only have to do this once, and I can just copy and paste for the other bracket and get rid of that, right? It's a left and right kind of thing. All right, so now the reason for this is now I can come in with my arc tool and I can snap a beginning arc to here, ending arc here, and then I can pull down and snap to the center there, and that gives me my sweep. Now, my sweep doesn't have to be as long. I don't have to go that far. I don't have to go all the way to the edges, but now I have the path to follow, right? Now I can offset that because it's got to be a groove. It's going to be a pocket that's getting cut out, right? So I can offset that line outward. Now, my bolt that's going to be going through there is a 1/4 so I'm going to go with a 9/32 inch opening. That'll give me some play and everything, and also it'll be about 0.26 something. So 9/32 equals 9/32 equals, and we're going to offset in both directions. It's 9/32 divided by 2. So take that number and divide it by 2 equals, and then create our offset. Right? Okay. So now we have our path for that tilting bracket. JR says, how about just putting holes in standard degrees, 0, 15, 22, 35 degrees, instead of putting in a slot? Holes would also provide more structured position. So you're wanting just a series of holes here to where you can pivot, tighten it in, pivot, tighten it in, pivot, tighten it in, right? So you can do, a series of, different degrees and stuff. I can understand that. I want one bolt going into my threaded insert on my dowel. When my plate pivots, I want to be able to tighten it down or loosen it. And I want to be able to swivel that plate anywhere that I need. I don't want to be limited to just going into holes. And now I have to use one of those holes. I can't just get it tilted just perfectly the way I want it, and stuff. But yes, JR, you can absolutely do that, right? I want the freedom of this range. So if I want a little bit of a tilt, a lot of a tilt, whatever, I can tilt it to whatever I want. And just all I'm doing is tightening one knob with a washer against the bracket. So, but yes, you can do 15, 22, 30, whatever, you can create your degree of holes and then you just pivot to that hole and tighten your knob and all. Sure. Put your bolt in. Absolutely. All right. So now I'm going to have kind of a cutoff point. I don't need to go all the way to the end of my bracket here. So I'm going to just come in. Let's see. Let's go 3/8 of an inch. And negative 0.3/8 of an inch. Oop. All right, give me 1 second. Let's try that again. Delete that one. Delete that one. Make sure we're doing a relative guide. There we go. Okay, and so here I'm just going to go into node editing on the vector, and I'm just going to cut the vector here, and down on this bottom one, I'll do the same thing. Cut it there. On the other side, cut the vector here. And there. So now that I have that, I can delete these vectors. Oh, not that one. I can delete these vectors out of here. I can select these two vectors here and just close or join with a smooth curve. So the this and this. Now let's go with join or close. Straight line. All right, let's go. Well, for some reason, my tools are not working today. There we go. No. What am I trying to do here, ladies and gentlemen? Bear with me just a second. You son of a gun, you. All right, let me try to get this damn thing to snap to its tangent. Now I should be able to trim to that. No. Nope. Oh, help me out here. Let me see. What am I doing? What am I doing? What am I doing? I need that circle to be. Let me draw a straight line. And if I snap that damn circle to the center, there we go. Lord have mercy. Okay. Come on, Junior. All right. So Shift H. Oop, no. I'm not at the center of my board. So I'll just mirror that, create a mirror copy, and flip it to the right. There we go. God almighty, all that for that. Okay. Join that together. All right, I don't need that little circle anymore. Now I have the bracket vector done. Lord have mercy. That was a work in progress. But now I have that sweep for the rotation and all. And so that part and this part, I no longer need this one. I can just come over here and hold down the control key and duplicate this one for those two brackets. So those are two parts that we're going to be cutting out of 3/4 inch wood. They are, it is, basically around 5x4, or 3 and 15/16, 3.9375. But so a 1x4, I can set those up. That's going to be one board. I can cut out of that. All right. Let's take this and this for the moment. We'll come work on that in just a minute. My drawer fronts, once again, I'm going to pull them over there. We'll see what this is, because it's not going to be the drawer front. We'll see what that ends up being. That's going to be not the drawer front, but the box, the frame front. These are the frame fronts. So these parts that I'm pulling here right now, if we go back to the design, to the front here, that is the front of the box. So again, that offset from where the height of this line to this line, that offset distance, that is depicted in Vectric as these two edge vectors. Okay, so that indicates the angle of the cut. I could, on one end of the board, that would be my long point, and the inside line would be my short point. Long point, short point, just like on a miter. Yep, JR, that could, let's see here. What stops things sliding off the shelf? Oh, there's a little part with a, let me show you here. Let me show you. It's coming up. Oh, that's not the top. Hold on a second. Let me grab the top. Okay. So there's a small piece here that, and also I'm going to have pockets cut in here. We haven't laid out that yet, but I want a pocket for the cell phone. I want a pocket for if I want to throw, a router bit or two, that's on standby, kind of here where I'm working or something. I'm going to create little pocket cuts in here and everything, recesses. So there's going to be pockets for that and stuff. But there's also this lip that kind of keeps the laptop and everything from sliding off and all. So that's going to be that. All right, let's look at the sides here. So let me take this and rotate this around. We have a left and a right. Now this side is 21 by 3 1/4, or by 12 3/4 by 21. And I have these brackets here. I have this drawn. I'm going to take these vectors here, and I'm going to copy them. And we're going to go into this project here, a completely different project, or vice versa. I could, take it over to a sheet and everything, which we'll probably do, but I happen to have this here. But this is going to be set up as a two-sided project for those grooves and everything to be cut in. And then on this side, we're going to have this decorative design. Now, let's take a minute, because it's already 9:39 and we're still laying out parts and everything, but let's take a minute and look at what we have. So the only thing that we have left is the back. That's a square piece that can be cut. That's the back of the box that can be cut on a table saw. We have the backs of the shelves. So you have your two sides, your back, and your fronts. The fronts are the ones with the double lines here. And then your actual drawer front also has the double lines and everything. But the smaller ones, I'll get the measurements and we'll measure to know which parts are which. But all of these parts here, these are just square cuts. We'll get the measurements of them so we can create a cut list. And I'm going to lay out all these parts for you guys and girls. And you're going to have a file that I'm going to release with all the sheets and parts and everything laid out that you could actually make this if you wanted to, if you chose to. Okay. All right. We still got to cut this part. I want to do the toolpath for this part. I really want to do the toolpath for this. So it's a two-sided job. We're going to set it up right now in just a second. But this is going to be important, an important piece, that transition from round to square and all that stuff. And we're going to have some fillets in here, but I want to do that next. These two parts. I'm going to, they are 16 inches by 22 inches. I'm making this, other than the drawer bottoms and everything, the top and the base, I want that to be kind of a decorative element. I want that to be a contrasting wood. So they're going to be, that's what they're going to be. They're going to be glued up solid wood panels. I'm not going to do plywood or anything. These are going to be solid wood panels glued up. So on the panel, this is 22 and a little under 3/16. But so I'm going to, out of a 24-inch board by 18 inches wide, we're going to have this, and it's the top and the bottom are the exact same. So we just cut it twice. Okay. So it'll be two separate sheets, but we're going to set up the sheet for that. Let's get that knocked out real quick. Add a sheet. This is going to be the top. I'm going to go in and edit this. It's going to be, let's go 18 inches by 24. The top could be 1/2 inch thick, but I'm going to go 3/4. So that'll be that. And then with that selected, I'm going to add a new, and it should duplicate the size. So now I can call this the bottom. Okay. So coming down to my original vector, this vector here, I can go ahead and right click and move to sheet bottom, move to sheet top. Okay. Come in here and center that onto the material. These sheets will organize once I get all these other parts out of the way. We'll take that, make sure it's centered. So that's going to be the top and the bottom. Now, the left and right sides, we will cut them out of here, and I'll just bring the vectors of that decorative panel over here. So these sides, again, they are 21 inches. Let's get back to sheet 1 here. These are 21 inches by 12 3/4. 12 3/4 at the long length, 8 inches at the short length. But 21 by 12 3/4. So we're going to come over here to our sheets, and we will create a new sheet. Oops. And we're going to call this our left side. Now, again, this is going to be solid wood other than the inside stuff and all, but I want the outside to be solid wood. So I'm going to glue up these panels. Almost, unfortunately 11 1/4, 12, 1 by 12, but I'm going to glue them up, the panels and all. So we'll have a left side and we'll have a right side. So on the left side, we will edit that, and the height, I'll be fine. The 21 24 is fine, but I only need to be, it's 12 3/4. I don't need to be much more than that. I'm just going to go 14. And then with that selected, I'm going to add new, and it should give me the same size, and I can call this my right side. Okay, so now we come back to sheet 1, select this, and so I want to think about, I got to orientate myself. So if that's the front, that's going to be the inside front. So that's my right side, and this will be my left side. So this one gets moved to the right side sheet. This one gets moved to the left side sheet. We go over to those sheets, select align to center. Select align to center. Now, let's take a moment and let's get the other vectors. Roger that. I did roger about the putting the 9/16 circle. Is that what you're referring to? What stops things sliding on the shelf? We got that. Roger that. Cool. All right. Let's take a second. Let's get the vectors for the decorative side over here. This is going to be a two-sided job, so we will be setting it up as a two-sided job. But let's switch over real quick. I'm going to save this, by the way. None of this has been saved yet. So let's go File, Save As. And this is going to be our Podium final file. Now, let's take a switch for just a second over to here. And I want to just talk to you really quickly about this pattern and everything, and about how we create, the offset and everything to create that pattern and stuff. So let's create that pattern once again really quickly. And I'll just do it. I'll do it right here. So I'm going to create a 1 3/4 inch by 1 3/4 inch rectangle right here. And then I'm going to create a 1 1/2 inch diameter circle in the middle of that. Find the center. And then I'm going to create a 1 1/4 inch circle in the middle of that. And then I'm going to create a 1/4 inch circle in the middle of that. Okay. Now with the ellipse tool, I'm going to come in here and I'm going to draw an ellipse, and I'll get it centered left to right and all that stuff in just a moment. But I want kind of a wide petal, and I want the ellipse to be sized down to where there's just a little bit of overlap on this inner ring and this circle. Now I'm going to center it left to right. So I'm going to align left, not to the material. Select that and select the rectangle last and align left to right to get centered there. And all I want is, I'm going to bump that down actually just a little bit more. I want a little bit of an overlap, kind of somewhat even, but not. It doesn't have to be and all. And I'm going to take this pedal here and I'm going to rotate it, doing a circular copy. I'm going to use a circular copy, and I'm going to rotate around the, make sure, by the way, that we're only selecting this object right here. But I need to put the rotate. Every time I click on that thing, it wants to move. But I need that pivot point. And what's crazy is my pivot point is not showing anymore unless I open the tab. So something's changed. I got to go back and figure out what I've got turned on or turned off. But that pivot point needs to come down and pivot around the middle of the center of this circle, which is the center of everything. And so with that, I can now come into the circular array here, and based on that pivot point, I'm going to go 4 copies around 360 degrees. I'm going to create those other 4 petals. Okay. Then with those 4 petals, I would just take the scissor tool and I would come in and trim here, there, here, and here, and then also on the inside too. So there and there. Okay, so that starts that shape. That creates that shape. Now I'm going to create an 1/8 inch wide rectangle that sticks up past or outside the circle by 1/8 of an inch. So the distance from here to here is 1/4 of an inch. Because if you remember, my rectangle is 1 3/4 and my circle was 1 1/2, right? So that should put 1/8 of an inch on each side. Sorry, not 1/4. That should be 1/8 of an inch here, 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 and here because of that 1/4 inch difference. So all I have to do is I'm going to take a rectangle and I'm going to draw a rectangle from one end of the rectangle to the other with square corners. And I want it to be 1/8 inch wide, 0.125. Okay. Then I'm going to center that. So if I select the big rectangle last, I'm going to align that to the center. Then I'm going to copy this rectangle, Control C, oops. Let's select that. Control C, Control V. And then I'm going to hit the number 9 twice. Once, twice. Copy that. Now, I'm going to trim everything, all these inside lines I don't want, and here, as well as, oops, not there. Let's undo that. My rectangle, let's come back to a full rectangle for a minute. My rectangle needs to go past the line a little bit. I'm going to hold the shift key and I'm going to go past the line a little bit on both of these. Hold that shift key. It'll do both sides at the same time. Now I'm going to trim. So basically I am trimming this away. The straight lines, get rid of the straight lines. All the lines in the middle, they can go away. It's only the outside stuff we want. So get rid of these straight lines. Get in, make sure you get in little corners and all. And then again, we're connecting this, that, and that, right? Over here, same thing. Get rid of this. Zoom in really tight. Get rid of that and that. And then trim away that. Get rid of the straight lines, all the lines in the middle. And then that. All right, so now we've created this shape. So we're going to group it together, G for group, and that's going to be the shape of our pattern, right? Now, we're going to rotate this shape 45 degrees. And I'm going to hit the number 0 key once, and it'll rotate counterclockwise. Now, when we have a shape like this and everything, and we're trying to create a pattern such as this, the distance between these rectangles and everything is 1/8 of an inch, you know, and all. And when you're trying to create a complex pattern like this, what you want to do is you want to create 4 of that object. So I'm going to take and I'm going to hold down the control key, and I'm going to go 1, 3, no particular order right now, 4. Okay. Now I'm going to, with these 4 here, this represents these 2 in a row. That's 1 row. This, imagine like there would be a whole row right here. That's another row. And this, imagine another whole row right here. So there's 3 rows, 1, 2, 3 right now of these parts. Now, if I take this part and I snap it up against my corner right there, and then I drag it away from that corner and type in 0.125 and hit enter, it'll move that 1/8 of an inch. So if I grab that corner and I move in a straight line, and I can just move in a straight line and type in 0.125 and hit enter, it'll move that 1/8 of an inch in that direction that I'm pulling it. And if I do the same thing here, if I snap this to its corner, again, grab it on the corner and pull it right along that pink line. So if I hold down the left mouse button and I pull on that line, 0.125, I only have to pull a little bit so it knows what direction to move it. Now I can select both of these objects, and I can come and snap them to this here. And then once again, grab it again and move it down the line. Make sure you stay in line. I fell off my line a little bit. Let me go. Always go back if you have to. Snap back to your corner if you if things mess up. But I want to move down the line. There we go. Try to move in one direction. I moved backwards. Let me move one direction. There we go. 0.125. All right. And that will create this pattern. Now, when you're creating an array, the array is based on gap between the parts, or offset. When you have an object like this, which is a complex object and everything, it's an offset. And an offset is the distance of the left side of one part to the left side of the next part in the same row. That's the offset distance. And then from the bottom of one part to the bottom of the next part in the next, or I'm sorry, column. I said column. So from the left side of one object to the left side of the other object in the columns. And then on the row from the bottom of one part to the bottom of the other. And that's how you determine what your measurements are. So if I came in here and I measured, I've got this layout. I need to know what my, what my offsets are going to be. So I need to kind of take some measurements. So if I come in here and I measure horizontally from the left side of this part to the left side of the next part in the same row, remember, these two are a row. So to the left side of this part, my number is 0.26582. Let me do that again a little bit cleaner. Let's go from here to there, and I'm going to pull that out there. Now I need to measure from the bottom of one row, part in one row, to the bottom of the next part in the next row. So that means measuring vertically from the bottom of this part to the bottom of this part. This one is a whole nother row. So think of like a row. There's 3 rows, like I said. So if I measure from the bottom to the bottom vertically, it's 1.304. And then I need to measure an offset. So imagine if these were in line with one another, there was no offset, there's no displacement. They would just be in a row, line of each other. But this one is shifted over so that it can kind of be in the middle of these two. So I need to measure from the left side of this part to the left side of this part. And that tells me my displacement. So now if I take a single object, let's close this. And let's move up here just a little bit. And I come into my array tool, I now can start plugging in my numbers. So my X offset, that's the row, is 2.6582. 2.6582. My Y offset is the bottom of one part to the bottom of the next for the, I said rows again. Sorry, my X is the columns. So this is one column, this is another. My Y is rows. So this is one row, this is another. So the bottom of this part to the bottom of this part, which is 1.3204. 1.3204. And then down here, the displacement, how things get shifted, every other row gets shifted. That's called displacement. And that's this number here, this 1.3309. 1.3309. And just by laying out those 4, it gave me the information I needed to lay out my entire thing. And so let's say I go 20 rows, 8 columns, and I click apply. It will create that pattern. Okay. So now that pattern as a whole could be centered over, and let's just, for example, let me take these 2 vectors and oops. So let's say that that's the my cabinet side, right? And the line, that offset, that's a 3/4 inch offset. That kind of represents where my drawer fronts and stuff like that are and everything. It really doesn't, I just want to kind of I want like a nice little inset pattern. Now with this, I need a trim line. I need a boundary. So I'm going to take this inside vector and I'm going to offset it inward 1/8 of an inch to kind of match all the rest of those, spaces and everything. So 0.125. And I want to sharp corners. I want to keep my sharp corners and select new, and that's going to create that offset. We'll use that in just a minute. Now I can take this entire array here and I can center it. Hold down my shift key. I'm going to hit G for group. And I'm going to hold down my shift key and I'm going to select this boundary here. And I'm going to align it to the center of that boundary. Right? Now I want to select everything, but I want to turn off. Let's zoom in really tight. Hold that shift key down. I want to turn off these vectors, right? My boundaries. And then I want to come back and ungroup these vectors, ungroup. And then I want to zoom all the way in and I want to select that inside trimming boundary that I created, that 1/8 inch offset. And I'm going to use the trim tool to clear everything outside away with that trim and everything. But before I do that, I might help the software out a little bit by getting rid of some of the things that aren't inside my object, right? That aren't inside my line and stuff. I just need to make sure I don't select anything that's going to touch the boundary that I'm using, right? So I can come in and, you know, help the software out a little bit by selecting some of these vectors and stuff and just, you know, getting rid of them, right? You don't have to be perfect, but just clean up the mess a little bit, right? Now, once again, I'm going to come in here, hold my shift key down and turn off these boundaries. All of these vectors have to be selected first. My trim boundary has to be selected last. And I want to clear everything outside of that boundary. I'm going to click clear. Now, this is going to take some time to clear. It's going to take some time to clear, to redraw all those vectors and all. And while that is doing that, we are going to go back to our, we can close out of this. We'll leave it open, sorry. We're going to go back to here and we're going to kind of start working on these two parts. Now, I know it's late. Your minds are racked. It's 10 o'clock. This is going to be the last part that we're laying out for tool pathing. And then we'll pop back and see that trim and all. But now you have an idea of how to make those patterns and stuff. And you can make any kinds of cool pattern that you want. Also, Vec Easy. Let's say that you didn't want to make your pattern. You wanted to just download a pattern and everything. Vect Easy. You can, sometimes they have free things like free panel designs, but you can also sign up and, you know, it's a small fee to be able to download all kinds of vectors. And Vect Easy, you know, just for a second, let's say I typed in bass fish, right? There's all kinds of cool vectors that I could bring into my Vectric software to trace and carve and things like that and stuff. Sorry, my screen's gone blank. It'll be back in just a minute. But let's go back to, let's hit back to the panel patterns. But Vect Easy is a great site. It's a cool site and stuff. But there's all kind of cool panel designs and everything that you could, you know, download, import, and trace. And sometimes you can get, you know, vectors, you know, they'll come as vectors and stuff from here. But there's all kinds of, you know, cool patterns and stuff like that that you might want to use instead of making your own, right? All right, let me get out of this because my monitor is going crazy while that calculation is happening. Okay, so let's come back in here and let's focus our attention. Let's go back to sheet 1, make it active again. And let me change the font color, or the the part color, to black here. But let's get this part here on the board. Now, this isn't the board we're going to use. We'll set up the board for it after we look at the vector and all. Now, what this vector represents is this hole on the side here. This hole is where the threaded insert would go, so that when you're raising. So let's look at the images here. Let's see if I can. Oop, too far the wrong way. Too far the wrong way. Okay, it's going to be the closest I have. But when these rods, when this top raises up, because you can raise it up so you can stand, you can lower it down so you can sit, whatever the case may be. With that raised up, this 1/4-20 bolt threads in and threads up against that rod and keeps it from moving, right? Now, Roger or JR, if you wanted to, on this 1 7/8 inch dowel, think about this now. If you wanted to create kind of a V-shaped jig, even out of a 2x4, you could take a 90-degree V-bit or whatever and cut it kind of a V shape, here, so that dowel can lay in there, on your table and clamp it down. You could come in and you could drill with your CNC a series of holes and put threaded inserts in there. So you have like kind of positive stops almost, to where when you slide this up, you've got a place, at certain heights. Right now it's a friction, right? So it's a friction. So this is raising up, those are screwing in, and it's pushing in against it, keeping it from dropping down. Now I'm using wooden dowels, right? This is now the actual podium here on the screen is metal, right? That's a metal rod. So, tightening the bolts into it to put friction pressure on it to keep it from dropping, it's not really going to damage that rod over time. But, with the wooden dowel, depending on how much I tighten or torque, I'm going to be kind of poking dimples into that dowel over time, right? And that might not be a desirable outcome if you want this to be something that's has a little bit of longevity. So we could take that 1 7/8 inch dowel and we could lay it out. All we have to do is draw a rectangle on in Vectric, and then lay out our holes where our drill pattern would be. And then we could actually drill those in that dowel, and then we could put threaded inserts and make sure the threaded inserts are sitting recessed flush, so that way the rods still move up and down, but we could have positive stops, right? So you can raise it up and you can lock right in. And it'll help keep things even as well too, and all that stuff and everything. But if I'm using wood dowel, friction's gonna, it'll be fine to start off with, but over time I'm gonna have a bunch of dimples, where I've tightened it too tight into the wood and stuff. So keep that in mind, right? So talking about positive stops and things like that for your swivel, but also positive stops for your raising and lowering. Food for thought. So that's what this this represents, the hole that goes into the side, that where that screws in. Now the vectors here represent the tube has a outside diameter of 1 inch by 1 inch square, and it's only got an 1/8 inch wall, so the whole thing slides over this. So this rectangle, all of this inside here is kind of pocketed out. And if we go back and look at the actual part, so if we come in here and select this part, I'm going to hit move M tool, but I'm going to hold the control key down so I'm moving a copy and not the original. And if we turn this over, this part, the 1 inch by 1 inch is that inside rectangle. And then we have the outside to give it some meat, right? That outside, which is, it is 1.5 by 1.5. So there's a 1/4 inch meat all the way around, right? And then, the transition, so that pocket cut comes in, let's see, get a tape measure. I've got it pocketing in 1 inch deep. The overall height of this is 1.5 inches tall. And so that means that this inner circle where the rod glides in and out is an inch and is a 1/2 inch. So 1.5 inches, right? And in this upper part, not down in the square part, in the upper part is where this circle's cut in for the bolt to slide through, because we want it to go into the dowel, not into the metal aluminum, right? All this, down here is going to be the metal aluminum. So this is the part. Now, when we carve this, we're going to have this 1.5 inch by 1.5 inch by 1.5 inch square cube. Okay. We're going to have it, positioned on the table. Now, here's what I would do. Here's exactly how I would do it. I would have a piece of MDF, 4 inch by 4 inch or whatever, with a 1.5 by 1.5 inch square cut into it for a friction fit, nice friction fit. And I would have that clamped to my board, and I would have my cube pushed down into it. It's the same way I make my dice, my wooden dice for like yard game Yahtzees and all. But my wooden dice. So that's going to go in. It's going to pressure fit in there. That's all the clamping I need. And then I'm going to come in and I'm going to cut the, the circle. That'll be the first tool path. Then this will get flipped a full 180 degrees, and I'm going to come in and cut the pocket. Right? Now, we can't fit a square peg in a round hole, so the corners of the inside of my pocket are going to have fillets so that, it'll slide over that square tube. So, and then after that, I'm going to flip it over on its side to drill that hole with the CNC. So my little 4x4 piece of MDF 3/4 inch jig with a little pocket cut into it so I can have my part sit in there. My X and Y would be off the corner of it or whatever. I would lay that out in here. And all three tool paths, once one was done, the board would get, or the little block would get flipped. Second tool path flipped, third tool path. So that's exactly how I would do it. And that piece of MDF is my kind of my holder, my clamp, if you will. It's a friction fit, but it's also my jig, because I'm going to be zeroing out on the corner of that so it knows right where to go to cut that part. So when we're in Vectric here working on this and everything, the vector itself, let's ungroup this. Oh, let's see here. What am I in? The drawing tools. Let's ungroup. And on the inner rectangle, that's going to be the rectangular part. That's the 1 inch by 1 inch. We're going to do the fillets. I'm going to be using a 1/4 inch end mill. So 1/8 inch fillet, dog bone fillet. I'm just going to go boom, 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 boom. Okay. So that way my bit, so I can fit the square tube in it. All right. Now, I'm going to take this vector and I'm going to make 3 copies of it. Okay. Hold down the control key, drag out 1, 2, 3. Now, The first copy doesn't need the vectors for the side hole, doesn't need the vector for the center. It just needs this vector here. It really, I want to keep that just for the layout purposes, but so that's the first cut. That's going to be the first vector that we're creating the toolpath on. Okay, we haven't set up the board yet. We'll do that in just a second. Second vector here, it doesn't need the side hole vectors. It doesn't need the outside square vector. It just needs the center. So after I cut that bottom, it's going to flip 180 degrees and the circle pocket's going to get cut, right? Now this block is 1.5 inches by 1.5 inches by 1.5 inches. So when we turn it to the side for this hole, we need to be able to drill that hole into the pocket here, but it really doesn't. We have a side view of it, right? We really don't have kind of a top view to help us with the layout, where it's going to go. So we need to rely on our design. So if I go to the design here, and I'm quite close to the edge, right? But, and I'll show you how to do it in Vectric too, but I want to be centered, right? Left to right, centered. And then from the bottom up 1 inch is the square pocket. From the top down 1/2 inch is the circle. I want to be centered in that 1/2 inch with this hole. And this hole is, it's a 1/4 inch hole, or 0.26 or something. So you have a little bit of play with it and everything, because the threaded insert, or, if you're not going to do the threaded inserts in the dowel, then the threaded insert goes in here, and you need to make the hole the appropriate size and all and stuff. So knowing that, here these vectors are going to go away. And I'm going to assume, I'm looking at the side here, and I'm going to assume from the bottom up. So let's say from the bottom up, I have that 1 inch square pocket being cut in there, right? And that leaves this 1/2 inch here. I don't need those vectors anymore. I know I need to be centered left to right, and I know I want to be centered here. Okay. I'm going to actually draw a line at the center point straight down to this line here, 1/2 inch long. That way it gives me something to snap my circle to. The circle, I'm just going to go 0.25 for right now. Sorry, I don't know why my 2 is not working. Let's fix that over here. There we go. But again, we need to make the hole big enough for the threaded insert. Now, the threaded inserts that I use, I love these threaded inserts. I get them on Amazon, and I'm going to share the link with you. Amazon.com. Give me just a moment. Let's go 2023 threaded insert. Click on that. Okay. So the threaded inserts that I use, it comes as a kit with a little tool for inserting the inserts. It comes with the drill bit, and it comes with the threaded inserts themselves. It is a 80-piece altogether. And I use the 1/4 by 10 millimeter high, 10 millimeter and everything. And they come in different, lengths or packages or quantities and things. But the one that I use is, it's on sale for $8.99. But this link Let me see if I can stand by. I'll see if I can paste it in the chat, and then JR, I'll answer your question. Content. Almost there. I'm trying to get to you guys on the other computer, you guys and girls. Go into the studio. And paste. So there is an Amazon link. Should show up there in just a moment. Yep. All right. And close out of that. All right. So, and Kool-Aid, if you're still with me, I don't know if I put you to sleep or not, but hey, I just want to thank you. That's your 5th super chat that you did for me earlier. Your 5th live stream where you did super chats. I appreciate that. So JR says, I'm a chunky boy, as the saying goes, and that requires a friction fit is guaranteed to slip a lot sooner than normal. It's the friction fit is not going to, now if you're talking about the up and down on the rods, but if you're talking about the jig for holding the part to cut and everything, you'll be able to get your 3 cuts out of it before it loosens up or anything. Because in the MDF, I mean, you're going down 3/8 of an inch in your pocket, so it'll be pressed in there, good depth and stuff. But if that's not the friction fit you're referring to, if you're referring to the knobs just kind of pushing in and stuff, if you've got your weight on it and everything, that's going to wear over time. Like if you're leaning on the desk, or on the computer or whatever, so threaded inserts wouldn't be a bad deal. And these would be the ones that I would use. But I put a link to those in the chat for you. And so these are the 3 tool paths. Now, just on that, what am I trying to say here? On that threaded insert, bear with me just a minute. The required diameter, let me see if it tells you here, if it tells me. Yes, it does. So the outside diameter it recommends is 10.5 millimeter, 0.413. That's the outside threads. That's not, I'm sorry, that's not the cut. Give me just a second here. That's the outside threads. We don't want to do that. The insert will just fall right through. Give me just a moment. .315. So 0.315, and the drill bit that's included with it that makes the hole. Give me just a moment. Give me a second. The drill is 9 millimeters. So 0.354. So it's a 9 millimeter drill bit they use, right? So we can pocket it out. It's 0.354. So we would just go if I was using that threaded insert here, if it was in the leg, now if it's in the wooden dowel, if I do the series of threaded inserts, in the wooden dowel, then this is just going to be a through hole right here. So the bolt passes through and threads into the insert that's in the wooden dowel. It's going up and down. If it's going to be some kind of friction fit like we just talked about and everything, then the threaded insert needs to be here, and you need to make your and I'm doing 9 millimeter, 9 times the letter I, and hit equals, and that'll convert it to inches. 9 millimeters to inches is 3.5433. But anytime you need to convert metric to inches, just multiply by the letter I. But if you're doing the threaded insert, then this hole needs to be, the size for that threaded insert, right? So I'm kind of liking, now that I've said it, I'm kind of liking the threaded inserts in the dowel. Every, I don't know. I got 80 of those threaded inserts. I mean, I can go every, raise it up, every 5 inches or something, so I have 5-inch increments or whatever to raise it all the way up. Kind of like that and stuff. I don't know. Y'all choose on that one. I will add a second vector here, a fourth vector here for y'all's file that I put out to you. One will be with the hole for the threaded insert, and one will just be with an oversized hole for your 1/4-20 bolt to pass through. Either one, and I'll create tool paths for both. But let's lay that, now that we have them laid out, that's our vectors for the tool path. Now let's go set up the sheet, and then we got to wrap it up because we can't go much longer. So this might have to go into a third one. But let's go to add a new sheet. Now for this sheet, I'm going 4x4, my piece of MDF, my little jig. So this is going to be my MDF jig. It's going to be 4 could be bigger. You can go 6x6, whatever you need, right? All I need is 4x4, 3/4 inches thick. In the middle, I need a 1.5 inch by 1.5 inch rectangle. Let's try that one more time. 1.5, comma, 1.5. I should have just hit 1.5 once and hit enter, not typing it twice. Center. Now, if I cut my block and I glue up my block and I cut it just right, because I'm going to make it out of a contrasting material, something that might look cool, walnut or whatever. But if I cut my block just right, then it's going to be on 1.5 inches by 1.5 inches, right? By 1.5 inches. So that means that my jig, I need to slightly undercut the vector for that friction fit. I need it to not a lot, a few thousandths of an inch, but I need it to be a pressure fit when I put it in. I don't want to have to beat it in. So when I do the for this jig, and this one here, I want to start in the corner, not in the center on this jig. That's a lie. I want to start in the center of that, so that's good. When I create the pocket cut, it's going to be, I'm going to go 3/8 of an inch. I'm going to use a 1/4 inch end mill. My end mill's got to have a place to go. Can't fit a square peg in a round hole, so I will have to put my fillets in there. And I will answer your question in just 1 second, JR, on the question you just had. The pocket allowance, it's going to be a positive number. Okay. A negative number. Nope, that's a lie. It's a positive number. Negative means it would make the hole bigger. Positive, it'd make it smaller. So my offset, I'm going to go 0.002. What'll be 4 thousandths and everything under on all the way around. When I calculate this. Now, if we go look at the 2D view here, in the solid view, you can see that I'm undercutting that 1.5 inch by 1.5 inch by that 2 thousandths of an inch on each side, right? If you need to make it bigger, you know, whatever you do. But that's where I'm starting with, and that's going to be a nice friction fit for me and everything and all. And so from there, I need to go back to here and get my vectors because they got to get thrown into that jig, right? So I'm going to move those to the MDF jig sheet. And JR says knobs. So knobs, you know, you can, you could, like make your own knobs and all that stuff. And that's cool and everything. We're not getting into that tonight or anything, but I buy knobs. So I'll show you the knobs that I buy. Let's see here. If you see weird things getting typed in the chat, that's because I keep typing on the wrong keyboard. Let's see here. 1/4 dash. All right, I got to change my search on my orders to trying to find my order. Give me a second, ladies and gentlemen. Okay. Let's come over here. Again, you can make your own knobs and everything. And they come in different sizes and stuff. These are quarter 20. Quarter 20. It's a 10 pack. The 4-star knob, 4-point knob. And it's $13 for a 10 pack. So that, you know, $1 something a piece. Right? Righto. Did I do my math right again? Let's see here. 1389 divided by 10. I don't know why I can't do math in my head tonight. Yeah, about $1.38 a piece, right, for the knobs and everything. But this, if I copy that link, we'll go back to y'all and paste it again. And then we're going to wrap up in 4 minutes, guys. Everybody's falling asleep here. Let's see here. Live. Okay, there's the link for that. All right, let's get out of that. Okay, so now here, I'm going to take and hit G for group, select each one of these vectors, G for group, and G for group. Now, these two, it's one or the other, right? It's not both. It's either the one with the threaded insert or the one with a pass-through, because your threaded inserts are in your rods, right? And we'll talk about more of that in the next class. But what we do now is we take that vector and we select this vector, and then we align to the center, right? And we're only using the inside vector here. So once we get it aligned, you ungroup it and you create your toolpath. So this pocket cut, it would be a pocket cut. It's going to go 1 inch deep, 1/4 inch end mill, and this is going to be the, I'm going to call it the pipe cap for now. I'll figure out a good name for it. Square side. Calculate. It thinks, so let me make the board, my jig, right? Let me make my jig pocket. Let me undo this real quick. Getting ahead of myself. So my jig pocket, I've already calculated that for 3/8 of an inch deep, I believe. Yep. And that is my jig. Okay. Now, I need to create another sheet. And this is going to be my cube, but it's going to still be the 4 inch by 4 inch, but we're going to make it the 1.5 inches. 1.5. Because we're zeroing out on the top of the cube. Zeroing on the top of the cube. All right. So let's go back over to here and okay. This vector is going to get copied over to the cube sheet. So we have it there just for visuals. And then these are going to get moved to the cube sheet. Okay. Now, one more time. Select this one first. Center it. Ungroup it. Select the vector. Pocket toolpath. Cutting 1 inch deep, 1/4 inch end mill. This is going to be my square side. I'll just call it square side. I haven't figured out a good name for it yet. I'll have everything cleaned up and named shortly, but that's going to be the pocket. Now, let's go up here. Let's stop that. We're not going to sit there. Go toolpath, simulation quality standard. And that way we can rock through that toolpath very quickly. Okay. Once that's done, that part gets turned 180 degrees, pushed back into the jig, zero out on the top because, you know, make sure you get it seated down in that jig, you know, right? Don't have it sitting cockeyed or whatever. Get it seated down in there. But still zero out. Don't assume anything. Zero out on the top. And the next tool path is going to be, let's ungroup that. Now I'm kind of just going to stack this. That gets centered. And it's the circle. This will get a pocket cut, and it's cutting a 1/2 inch deep. You can even go a little bit more so it cuts through nice and clean. That's up, but you calculate that tool path. Okay. So on the other side, when you flip it 100, sorry about the blacking out of the screen. It does that when it's calculating. Don't know why it's been doing that. I gotta get that. It's a connection or something. And then once that one's done, then, and I'm just gonna do the one with the pass-through hole for now, but oops. That pass-through hole. We flip the block. Think about your block, and it's all the same, even all the way around, right? So pick a side, any side. That's going to be your outside, right, where the hole is going to get cut. And you're going to do a pocket cut, and this one's going to go through, right? So this wall here, it's got to go through this hole here. So if I measured, where's my measure tool? If I measured from the edge of the circle to the edge of my block, we're at 3/8 of an inch. That's not 3/8, that's 5/16. We're at 5/16 of an inch, right? So my pocket needs to be a little bit deeper than that, right? So we'll go 0.32. Or 0.33, it doesn't matter. 0.33, it doesn't matter. 1/4 inch end mill. Select that vector. Calculate, right? And so that in that other side, that cut will be, you know, cut in, you know, going through and stuff. And now, and that creates a block. And you do that twice, right? You do it twice. All right, everybody, ladies and gentlemen, we are going to stop it here for right now. We've got the tool pass for the little blocks. We have not created the tool pass for the inside sides yet, but let's go look at that panel that we trimmed, so you can see what that looks like, that panel that we trimmed. After the panel gets trimmed, ladies and gentlemen, this vector, the one that we use to trim to, which is this vector right here, that gets deleted out of the project, deleted out, right? And so that would be your inside panel. So this vector, I'm going to select it, and I'm going to copy that. And in our other job, I'm going to go to the left side, and I'm going to make sure that's all grouped. It is. I'm going to come in and paste that here. Move it closer. And that'll end up getting, we're going to set that up as a two-sided job next time around. We'll set up as a two-sided job and everything. Now you kind of get the gist of what's going on. I'm still going to have the files, yes, saved. I'm still going to have the files ready to download like in a couple of days, right? So you can go ahead and start working on this, but we will kind of wrap up this job, you know, fully, completely, because we got to create the tool paths, you know, for the side panels. And then I need to lay out the pocket areas that I want for the top. You know, I want a place for my cell phone, you know, pens or pencils, a little router bit, like if I have an end mill or a V bit or something that I need to, you know, set down for a minute or whatever, because I'm about to change to it or something. I want to make little pockets and things in the lid and stuff that's going to suit me. I'm also, we'll talk about it later, but I've got to make that little strip and all. So we'll wrap that up. Unfortunately, this is going to roll into a side 3. It's taken a long time to get to here. But a lot of these parts are going to be table saws. But in the meantime, what I'll do is when I have the files ready, I'll have all your cut list created. I have all your cut list created and everything for all these parts, the table saw and chop saw cut lists and angle cuts and all that stuff. Everything laid out and written out for you. Thursday, we're doing an Easter project. If you want to join us live at 7:30 here on Spindle TV, we're doing an Easter project Thursday evening. It's going to be open to the public. My paid subscribers, tomorrow night, we'll see you. I haven't come up with the topic yet, but it's going to kind of continue on that beginner modeling. We're going to continue on into a little bit more into it and kind of get that series wrapped up. But Thursday night, everybody, we're doing an Easter project, 7:30. If you want to see us, see you there. Now, it's been a long night. For those of you that are still with me and still awake, thank you for hanging out with me this many hours, you know, on this project and everything. Sorry that we didn't get it completely done, but you will have the files this week. Like in a few days, you'll have the files to actually be able to, like if you want to go ahead and, oh, I know what to do from here or whatever, go for it. I'll have all the tool paths ready for you and stuff. But we will wrap this up on Thursday. You'll have your cut list and everything, and then we'll go from there. Now, I'm actually making this. I am making this. So one of the classes or one of the lives that I do is going to be making this project. And I just want to take a quick second and share with you something as I say goodbye. So the other day, I don't know if any of you know, but I picked up a used, pre-owned 4848 digital wood carver 4x4 machine and got it moved into my little shop. My big shop, we're still working on electricity and everything. So I need this to get into production now. So I got it into my little shop, and the unit is I'm very happy with it. I have a 24x40 cutting area machine behind that. It's kind of back in the corner back there. But this is my new 4x4, new to me 4x4 that I picked up. And so we're going to be out in the shop. I'm going to be making these parts we're going to be doing, assembly and stuff. I'm going to have some of the parts already made, but some of the little parts, like maybe the jig and the cube will cut. We'll cut, some other things, but Ronnie, it does not have an automatic tool changer yet, but we do have automatic tool changers coming out for the 4848 and the 5100. So in the future, I will be putting one on, but not right now. But I will be making the parts. I'll be cutting these out and everything. So one of my lives, I don't know if it's actually going to be one of our classes. It might just be a live that I throw out there or something, but is going to be me in the shop. And you guys, if you want to hang out with me as we cut and assemble and build this thing, I'm going to build it. So, I'm going to just understand that I'll have the panels pre-glued, of course, and everything. I'll have my other parts cut to size. My table saw is in the other shop. So we'll just be building, right? We might be doing pocket hole screws and things like that. And, getting things built, nailing on and gluing the bottoms and all, making all the drawers and stuff. But could be something interesting you might want to be a part of or hang out with me on that and everything. So Ronnie wants to see me work it. All right, everybody. We will have a follow-up video finishing up the tool pass, but we will also have a follow-up video at some point in time of building this. Well, we're going to make it live and everything. And then the Wednesday night live class for my paid subscribers, guys and girls, we're going to do 3D modeling basics for beginners. Part 2, wrap that series up. And we'll probably get into some other things. And then Thursday night, public Easter. If you guys and girls want to join the private community, I would love to have you join my private community. Click the join button on my channel. $9.99 for a silver membership, $19.99 for a gold membership. It gives you perks. The members, the paid members, they get to see any content and stuff that I release that's not live. They get it 24 hours ahead of everybody else. So they get kind of a sneak peek. They have access to a private group on Facebook where we talk and collab and work together on different things. And we do live classes every Wednesday night. And gold members get to come on camera with me every Wednesday night. So if you want to become part of that community, that exclusive community, click the join button on the main channel, Spindle TV main channel, and everything. So, all right, everybody, y'all have a wonderful evening. Thanks for hanging out with me this late. We'll see you in a few days.